Hello everyone, I'm Chengcheng. Today I'm glad to present our work on PracExtractor, extracting configuration good practices from manuals to detect server misconfigurations. This is a joint work between UC San Diego and NetApp. Our lives are largely supported by online services today. Especially under this quarantine, almost everything we are doing is through online services. Behind these online services, what serves us are these powerful and complex data center systems. Many different programs are running on hundreds of thousands of machines to handle our requests. One thing in particular has become highly complex is the configuration of data center systems. Let's take a look at the common software that runs in data center, like Hadoop, MySQL, Apache, etc. They all have hundreds to thousands of parameters need to be configured. And what makes things worse is many of these parameters are correlated. That means when you change one parameter, you may need to change another one. To tackle configuration complexity, currently most software release large manuals to assist sysadmins with configurations. These manuals can have hundreds to thousands of pages. With so many pages, manuals are too long for humans to read. And also, manuals are hard to navigate. They are usually organized by parameters. If you don't know which parameter to change, it's hard to find the related content. As a result, sysadmins usually turn to online forums like Stack Overflow to resolve their issues. Online forums may provide unreliable answers, which may be only partially correct or correct in certain conditions. Based on this work tries to study software manuals to see if there is any useful information related to configuration that can be automatically extracted from manuals so that we can build automatically tools to help sysadmins check their configurations. Yes, we found something promising called good practices that can be helpful. Good practices describe how to set parameters in a good way from users' experience. Here are some examples of good practices from different software manuals and for various parameters. For example, the second row describes that in HTTPD, it is recommended to set the parameter extended status off for highest performance. Breaking these good practices can cause various serious outcomes, including performance downgrade, security vulnerability, and reliability issues. To further validate if it is worthwhile to extract the good practices in manuals to build checkers, we further study three questions. First, are those good practices specific or general? If good practices are general, like set it to a large value, they are not helpful for checking. Second, are good practices already checked in source code? If they have been checked in the source code, that means the software itself will probably give warnings when sysadmin's configuration violates these good practices. It is then not necessary to extract the good practices from manuals to build another checker. Third, are good practices always equivalent to default setting? If they are, then sysadmins can just leave configurations as default in order to follow all the good practices. We collect 261 good practices from 6 software manuals and studied them to answer these questions. For the first question, the answer is 60% of them are specific. This bar chart shows the number of specific and general good practices described in different software manuals. As most of them are specific, the good practices can be extracted and then be used for automatically checking. For the second question, only 3% of specific good practices are checked in source code. This bar chart shows the percentage of these good practices. It indicates this program themselves will not generate warnings if most good practices are violated. As a result, if we can extract these good practices from manuals and do additional checking, then we can warn sysadmins about these violations. For the third question, 61% of specific good practices are not equivalent to default settings. This pie chart shows the percentage, and the stack bar in the right side further decomposed the reason why good practices are not equivalent to default settings. The most frequent reasons are multiple values and conditional good practices. Multiple values means a good practices may recommend multiple values to have sysadmins choose the one that best suits their environments and requirements. Conditional good practices are those good recommended value, but based on some condition. For example, if parameter A is enabled, it recommends to enable parameter B. 13% of them are because of some non-optional parameters have no default. 6% of them are because some good practice recommend relatively values, like 20% of the memory size. The remaining 4% are those we don't find a clear reason that they should be different. We report this 4% to developers, and one of them are confirmed as bugs in the default values. Based on the study, we designed PracExtractor to first extract good practices descriptions from manuals. For example, the second sentence describes for parameter P2 a value between 8 to 16 is suggested. Then PracExtractor converts these text descriptions into checkbox specifications. P2's good practice have been converted into a range. With the converted specification, PracExtractor checks sysadmins config to see if there is any violations. In this case, P2's value violates its good practice, and so a warning is generated for sysadmins to double-check this configuration. PracExtractor faces two challenges. First, as manuals are written in plain text, and they have a large amount of text unrelated to good practices, how to effectively filter out these noises and extract only good practices? Second, even after PracExtractor extracts good practice descriptions, these descriptions are all in free text. How to convert them into formal specifications that can be used for automatically checking? For the first challenge, PracExtractor adopts both keyword filtering and syntactic pattern filtering to extract good practice descriptions. PracExtractor first extracts sentences that contains practice-related keywords as good practice candidates. In this example, the first and second sentences contains keyword which is recommend, and so are extracted. The third sentence contains no keyword, and so is filtered out. PracExtractor then adopts syntactic pattern filtering to further filter out non-good practices from the candidates. In this example, although the second sentence contains keyword recommend, it recommends nothing and so it's not a good practice. PracExtractor performs syntactic dependency analysis for each sentence. We observe that good practices and non-good practices typically have different syntactic patterns. For example, the first sentence and the second sentence has a different syntactic patterns. The second sentence are not good practices, and so it doesn't have the specific syntactic patterns in the good practice sentences. PracExtractor then uses the good practice specific syntactic patterns to identify real good practices. For the second challenge, PracExtractor also takes 2 steps to tackle it: setting entity identification and semantic pattern matching. For setting entity identification, PracExtractor identifies entities such as enums, integers, and parameter names, etc. In this example, CRC32 is identified as enum, 8 and 16 are identified as integer, and thread per child is identified as a parameter. Then, PracExtractor uses entity-based semantic patterns to match with each tagged sentence. For each pattern, PracExtractor generates specification correspondingly. Here, the semantic pattern along with previous syntactic patterns and keywords are mined from the 6 software manuals in our characteristic study. We will show their generality by using them to extract good practice specifications from 6 new software manuals that are not included in our characteristic study. We evaluate PracExtractor with 2 sets of experiments. First, we use PracExtractor to extract good practices from software manuals to evaluate the extraction accuracy. Second, we use the extracted good practice specification to detect real-world configuration errors. For the accuracy of extracting good practices, we use 6 studied manuals included in our characteristic study as a training set. We use another 6 new manuals not included in our study as a testing set. Here are the results. The training accuracy is in blue and the testing accuracy is in orange. We used 2 metrics to measure the accuracy. Precision means what percentage of good practices extracted are true good practices. Recall means what percentage of true good practices are extracted by PracExtractor. The left 4 column shows the precision and recall of extracting good practice descriptions. We can see both for the studied and new manuals, the precision and the recall can reach a number over 80%. The new manual's precision and recall are only slightly lower than the studied one. The right 4 columns shows the precision and recall for specification extraction. The precision for the new manuals is close to the studied manuals. The recall for the new manuals is lower than the studied manuals. This is because some semantic patterns only exist in the new manuals, but not in the old manuals. It can be further improved if we incorporate more data in the training set to include these new patterns. To evaluate PracExtractor's capability on detecting real-world configuration errors, we downloaded 2,200 Docker images from Docker Hub for PracExtractor to check to see if there's any violations. PracExtractor detected 1,423 practice violations from 853 unique images. We reported 325 violations in repos that are maintained on GitHub, and got 47 of them confirmed as real configuration errors. We further analyzed the outcome of the confirmed configuration errors. 31 of them will cause unreliable services, which leads to occasionally failures. 11 lead to security holes that make server vulnerable to attacks. 3 cause database inconsistency, and 2 cause performance issues. This indicates the good practice violations indeed can cause severe outcomes. As a result, our PracExtractor can help sysadmins detect these severe misconfigurations. We also analyze the characteristic of the detected violations. We divide them into wrong changes and wrong defaults. Wrong change means a parameter setting is changed to a value, violating good practice proactively by sysadmins. Wrong default means a parameter default setting violates good practices, but is not changed by sysadmins. Here are the results. The most common violations are wrong defaults. This implies that sysadmins tend to leave default settings as they are. In this case, our PracExtractor can help sysadmins check these wrong defaults and warn them about the violations, so that they can double-check these settings to avoid these potential misconfigurations. Another interesting observation is that HTTPD has many cases of wrong changes, which differs from our other software. We looked into this and found this is because HTTPD has many non-optional parameters that has no default. In this case, sysadmins have to set these values for themselves. This indicates sysadmins indeed fail to follow good practices in manuals when making their own settings. Our PracExtractor can help sysadmins detect these violations and then further provide the good practices for them to correct the violations. To summarize our study, we first identified good practices as a useful information from manuals that can be extracted from with NLP techniques, and then with this extracted good practices, we can use them to build automatically tools to detect configuration errors. We studied 261 good practices from 6 software manuals to provide usefulness to prove the usefulness of the good practices. Then we built PracExtractor to automatically extract good practices from manuals. Our evaluation shows that PracExtractor can achieve a reasonably high precision and recall. PracExtractor can also detect 47 real-world configurations errors that have been confirmed by those image maintainers. With this, I would like to conclude my talk. Thank you for listening to my talk. Please feel free to email me if you have any questions.